Hello, everyone. Mr. Minix, my name. Math is my game. I'm joined with my Algebra 2 class today. And what we're looking at, we're kind of backtracking for a minute, and we're going from Chapter 8. We went into Chapter 7 for a minute, and now we're back to Chapter 6 because we need to study inverse functions. And before we study inverse functions, we need to back up and look at square roots and radical expressions. So that's what we're looking at today. I really wish I had a good impersonation of someone who was a skater type. I do a pretty good impression of Bill Clinton. Somebody was complaining to me about something, and I said, "I feel your pain." So that's my Bill Clinton impression. I don't really do so well of a skater impression, but we are going to be studying radical expressions. So just a reminder, when you hear the word radical in mathematics, it just means this symbol right there, okay? That's all we're talking about. That's what we mean when we say radical. Sometimes we'll abbreviate it by saying rad this and rad that. Something that goes along with the radical is an index. An index is simply the number or not there. My microphone was off, so the index is the number in the notch. The index is the number in the notch. I don't think that's going to show up in words. That's supposed to say notch, not note. So if we talk about the index, we're talking about the number in the notch. Now, does anyone know the right way to abbreviate the word index? It's kind of, it's indices, indices like that. It's not indices, it's indices. So if you're talking about more than one of them, it's indices. But okay. So anyway, by default, and when I say default, I mean if there isn't one. By default, comma, the index is some number. Even though we don't write it, it's there. Just like a coefficient that isn't there is really 1 if there's a term. Just like an exponent that isn't there is a 1. Just like a denominator that isn't there is a 1. Well, in this case, the index isn't 1. Does anybody know what it is? It's not 0. It's 2. Because if we don't write an index, it's a square root. Okay? So without an index, it's a square root sign, which means what number can you multiply by itself 2 times to get the number whose square root you're taking. Okay, so keep in mind that that number is called the index. So when I talk about the index, we're going to be putting different numbers in there, such as 3, 4, 5, 10, maybe not that big. Okay. Speaking of which, I did mention that there would be a test around the corner. I just need to type it up. It's a chance for you to boost your test scores. So here's what you need to know for that test that's coming up. Powers. It's going to be a powers test. I expect you to know squares of the following numbers. Squares of 2, 3, 4, 5, well actually 1 also, 6, all the way up to 20. You should really know all the way up to 20 squared. We did this a while ago, yeah, perfect squares. In addition to that, anything that ends in a 5, I would expect you to be able to square those now. So for instance, 25, to square 25, you take the 2, and what's one digit higher than 2? 3. Well, one integer higher than 3, or 2 is 3. So 2 times 3 is 6, so 25 squared is really 625, okay? So let's try that with maybe 35. What would 35? What would 35 squared be then? 12. 25, right? Because 3 times 4 is 12, so it'd be 1225. Okay. So I do expect you to know all those squares. Then let's move on to the cubes. Cubes of 1, cubes of 2, 3, 4, 5, 6, and 7. And yeah, up to 7. It doesn't hurt to know 8 cubed also, but so cubes of 1, 2, 3, 4, 5, 6, and 7. Can I list them? Sure. So 1 cubed is 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is, back in the day, I wish I had an Impala 6-foot, and 5 cubed, back in the day, I wish I had a Yamaha YZ 125. And back in the day, the area code was the area code in Garrettsville used to be 216, and then yeah, and then 343. Okay. So those cubes, and then fourth powers of 1, 2, 3, 4, and 5, we'll say. So let's think about the fourth powers of 1, 2, 3, and 4, and 5. 1 to the fourth power is still 1. And 2 to the fourth power, that's 2 times 2 times 2 times 2. If you want to know what something is to the fourth power, just square it and square that. So let's see. 2 squared squared is 4 squared, or 16. And 3 squared squared is 9 squared, or 81. And 4 squared squared is 16 squared, which we should know is 256. And 5 squared squared is 25 squared, which is 625. Okay. Finally, fifth powers of, so we should know the fifth powers of 1 and 2 and 3. And that's probably good. So 1 to the fifth is 1, 2 to the fifth is 2 squared squared times 2. It's 32, right? And then 3 to the fourth was 81, and 81 times 3 is going to be 243. Okay. Are you going to have a lot of time on it? You're not going to have enough time to multiply them, so yeah. Finally, one more thing on this. You should know powers of 2 all the way up to 10. 2 to the powers, actually 2 to the powers negative 3 through positive 10. In other words, if I said, what's 2 to the 0 power? What's 2 to the first? 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh, 2 to the negative first, 2 to the negative second, 2 to the negative third. And I'm going to slide all those down here. 2 to the 8th, 2 to the 9th, and 2 to the 10th. You should know all those as well. When's this test going to be? Sometime next week. Sometime next week. It'll be worth at least 50 points. I won't give you a day's notice, but I won't do it on Monday. So, let's see. I bet the tattoo shops are going to be busy this weekend. Just kidding. That was a bad joke. Okay. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. All we're doing is doubling it as we go to the right, right? So then we got 32, and then 64, and then 128, 256, 512, and 1024. Interesting story about 1024 is this. I really wish I taught a computer class, because I would ask this on every single test I gave in that class. How many megabytes are in a gigabyte. It's not 1,000. It's 1,024. Computer memory doubles, and that's why everything is a power of 2, because memory always doubles. Everything hinges around powers of 2. That's why if you buy a memory card, it's 32 gigabytes or 32 megabytes or whatever. So anyway, let's see. 2 to the 0 power, what's that going to be? 1. And 2 to the negative first power is... I'm excited about this one because nobody said negative something. Thank you for not saying negative something. It is 1/2. And then 2 to the negative second is a 4, so 2 to the negative third is an 1/8, right? So sometime next week you will be given a test. It will go in the grade book as a test. So you're going to need to know all 20 perfect squares, how to square something that ends in a 5, the cubes of 1 through 7, the fourth powers of 1 through 5, fifth powers of 1 through 3, and 2 to all those powers. Yeah. And you might say to yourself, why at this point in our high school careers, why would at the end of the month, with 6 weeks of school left, why would you ask us to memorize these things? You're just doing this because you want to give us another grade. No, I'm not. I would like to give you another grade. I would like you to have a chance to help your test scores and improve them. Also, if you know these, when we get to logarithms in Chapter 7, you're going to breeze right through them and they'll be a piece of cake. If you don't know these, you're going to struggle with logarithms. I'll be honest with you. So there is a reason to the madness here. Okay? We all set? Good. All right. I'd like to give a shout out to the future Mr. Minnick. Probably back at his desk. No, I bet he's sitting down taking notes. Anyway, this key concept page has got a lot of good information, but it's kind of confusing. If I could, let me just summarize it for you. If we have an odd index, so for instance, something like the third root of something or the fifth root of something, that's how it's read. It's an index of 3 or an index of 5. It's read the third root of, the fifth root of. All we're saying is the radicand can be negative. The radicand can be negative, and there is one real root. Now you might remember from chapter 4 when we studied square roots, if we had the square root of negative 1, remember what that was called? The square root of negative 1? It's I. It's not real. It's imaginary, right? So what's going to happen here, we'll go to example 0.1. Example 0.1, find the third root of negative 1. In other words, what number multiplied by itself 3 times would give you negative 1? And some people say no real solution. Well, that's not true. Some people would say it's imaginary. That's not true. Some people would say there isn't one. Well, that's not true either. Let's think of a number that we could multiply by itself not once, not twice, but 3 times to get negative 1. Negative 1, yeah. Negative 1 times negative 1 times negative 1 is negative 1. So the answer to this is negative 1. Now, the TI Nspire sometimes lets you down. Most of you know that I'm a big power sports fan, huge power sports fan. I love ATVs, motorcycles, that kind of thing, right? And you know I like anything that's fast. Well, Can-Am probably makes some of the best ATVs out there right now as far as fast, fun to ride, really awesome. They sound great. They look awesome. They cost $1 million too, but that's another story. So the thing of a Can-Am is this. If you're riding a Can-Am through a mud hole and mud clogs up the air intake for the belt system, you're going to be walking home because the belt's going to fry on you. And you're not going to be able to change the belt out on the trail because it's hard to change on those. from what I hear. What I mean by that is the TI Nspire is the same way. This is a big fancy machine. It does a lot of great things, but if it's not set up the right way, if it's not set up properly, it's going to let you down with some of these. Just like some of you on your quizzes, by default, these things are set up to float 6. And on some of your quizzes, you were getting the wrong answer because the calculator was set up to float 6 and you needed to set it up to float. If I set my calculator up to handle rectangular coordinates, let me see what happens here. So if I want a third root, the calculator has actually got that. There's my index of 3. Let's try that again. My index is 3. My radicand is -1. And it actually gives me the answer there. Okay? Home, settings, document settings. Let me set it up to handle rectangular, I said. Back to the current. Let's try that again. Do you see how the Nspire just messed that up? It's supposed to be -1. But if the Nspire is set up the wrong way, it's not going to do what it's supposed to. ATVs are just like that. If you put a clutch kit on it and you don't do something about the belt, if you don't upgrade the belt, it's going to break down on you. And this is the same way. Okay, that's why I was talking about those, not to bore you with ATVs, just to show you that the Nspire sometimes will give you the wrong answer. Where did it get that? So the Nspire, when it's set up for handling imaginary numbers, which you have to put it in a rectangular mode. When it's set up to handle imaginary numbers, anytime you're dealing with odd indices, it's going to give you the wrong answer. It's going to give you the wrong answer. Where exactly you got the answer from, I don't know, but I know that it's not the right answer. So I'm glad you asked that question. Now I'm going to have to look it up. Okay. So just be aware of that, that the calculator sometimes will give you the wrong answer. So let's go old school. Let's go to something that's got a foot clutch that we have to shift with a foot clutch. Let's see what happens here. So let's go with the third root of -1. This says it's -1. Now if I set my calculator up here to handle imaginary numbers, if I set this up to handle imaginary numbers, let's see if it still gives me the right answer. It does. No matter what, that one gives me the right answer both times. A Lamborghini with paddle shifters? Throw it in Mathway? Okay. So let's go to Mathway. Mathway. Mathway, here we come. Okay, enter a problem. Where do I get my... Oh, look at that. Third root, -1. Evaluate. Answer. Boy, that took a long time, but it's right. But it's right. So that's a Lamborghini with paddle shifters. Okay. I like that. That was good. I'm going to use that. Example 0.2. Evaluate the third root of -8. In other words, what number multiplied by itself not once, not twice, but 3 times would give you -8? -2. Good. We get the hang of this kind of a little bit. Pretty easy so far. So notice I started off when we have an odd index. That's true when we have an odd index. The radicand is allowed to be negative. And there is just one real root. Let's do one more. Example 0.3. Evaluate the fifth root of 32. In other words, what number multiplied by itself not once, not twice, not 3 times, not 4 times, but 5 times would equal 32? And this is why we got to know these things. Let's back that thing up a minute. This is why we got to know our fifth powers of things. So it's going to be 2, right? Whoa, where'd we go? We're 2 pages down the road. So this is going to be 2. How's everybody doing? Now notice we didn't put a plus or minus there because a negative times a negative is still a negative. So the SIG and the sign has something to do with this. Okay, so there is just one real root. The radicand can be negative. Everybody all right so far? Okay. So now let's look what happens if there's an even index. If the index is even. If it's an even index. So why did I write IDEX? Why did I not put the N in there? I forgot the N. Can't forget the N. Okay. So if we had the square root or the fourth root, okay? So the deal here, there's a couple things to consider. If the radicand is negative, the result is non-real. If the radicand is negative, then the result is non-real. And we saw that in chapter 4. The next part is kind of confusing, and it depends on the context. The next part is this. There are 2 roots when, and in fact they're real roots. There are 2 real roots when the radicand is positive. There are 2 real roots when the radicand is positive. And one of the roots is Mr. Dobrin, Mrs. Mulhern. There's one called the principal root. And anytime we talk about the principal root, what we're talking about is the positive root. Okay? It's the positive root. The other one, some people call it the secondary root, or some people just call it the non-principal root. Okay? I'll just say the other one. The other one. And this is the negative one. Okay. I haven't seen any clear indication as to whether it's called the second root or the non-principal root. But it's the one that is negative. So I guess we're going to be on example 0.4 if I'm not mistaken, huh? 0.4. Example 0.4. Example 0.4. Evaluate the fourth root of negative 81. So what's the fourth root of negative 81? Three? Well, let's ask one of our calculators. Negative 3? Let's see. 4 math x root, fourth root of negative 81. Now it says it's 2.12 plus something. Plus what? I don't know. So let's run over and see. Oh, there's an I in it. There's an I in it. There's an I in it. Oh, wait a minute. Did we read what we just wrote down there? Does anybody know what the radicand is? Hold on a minute. Time out. What's the radicand? When I use the word radicand, I fear that we don't know what that means. The number under the root. The radicand is the number under the root. If that's negative, the result is non-real. So what's the deal with example 0.4 here? It's imaginary. It's non-real. And it's not 3. Okay? So the deal is this is non-real. All right? So let's juxtapose that with another one, with one just like it, but a little different. Example 0.5. Evaluate the fourth root of positive 81. What do we get? We get 3. And 3 is the only answer here. Because 3 times 3 times 3 times 3 equals 81. Okay? Let's go to example 0.6. Example 0.6. Find all real roots of the fourth root of 81. What's the answer here going to be? Three, 9, and 27? No. Let's go back and look at what else we wrote just a second ago. There are 2 real roots when the radicand is positive. Yeah. 3 and negative 3. There we go. It's going to be 3 and negative 3. Okay? The answer here is 3, which is the principal root. 3 is the principal root. And negative 3, which is the other one. The other one. It's kind of like when you have a pair of people, and you know who the one is, but you have no idea who the other one is. Isn't there a boxer that has like an entourage of people, and most people know who one of the members of the entourage is, but nobody knows the other ones? It's kind of like that. It's kind of like that. Do we see the subtle difference in the directions between 0.5 and 0.6? Do we see that subtle difference? When it asks you for all the roots, we got to find both the principal and the other one. When it just says to evaluate, just the positive one's okay. What do we think so far? We doing all right? Well, let's go to some of the examples in the notes here and see if we can do these. What are the real cube roots of the following numbers? 0.008. Whoa. Now, we know that the real cube root of 8 is 2, so it's got to be some relative of 2. It's 2's cousin. So what do we think for this 0.008? What do we think that's going to be? 0.2. You're right. It's 0.2. What about for negative 1,000? What about for negative 1,000? Negative 10 is correct. But you sure it's not imaginary? You sure it's not imaginary? It is real. Remember, when the index is odd, we can't have negative radicand. So yeah, this one is negative 10. And then 1/27th, what's that going to be? Not 3. A third. Good. That one's going to be a third. This isn't so bad, is it? Not really. Okay. Real fourth roots. Let's start with 1. What's the real fourth root of 1? What's the real fourth root of 1? 1. Good. What's the real fourth root of negative 0.0001? Yeah. Well, let's think about this. What happens if the index, here the index is even. Here the index is even, right? What do we know when the index is even? Can we have a negative radicand? No. And it asks us what's the real root of negative 0.0001. I'm going to break it. It's non-real or imaginary. And they're asking us what's the real one is. There isn't a real one. Can I say this? Can I say date 1? Can I say that? Date 1? Okay, I'm going to say that. Date 1. What about the real fourth root of 16 over 81? Of 16 over 81. So with the fraction, we just split it up. Our rules from radicals with fractions and stuff works again. So we got to think about the fourth root of 16. What's that? The fourth root of 16 is, it's not 4, it's 2. And the fourth root of 81 is 3. So there we go. We get 2/3 there. Okay. How are we feeling? We got this? There's this one section down here that says, that asks if you got him or not. So, if you got it or not. Do we need to do those, or are we pretty solid with this? Good? All right, we're moving on then. Moving on. What is the third root of -8? Well, we already did that one. We know that's -2, right? What about the square root of 0.04? The square root of 0.04. Honestly, I think if you think of that as a fraction, it's easier. What's the square root of 4/100ths? Wouldn't it be 2/10? You see how thinking of fractions makes that easier? It's 2/10. What's the fourth root of -1? What's the real root of the real fourth root of none? Good. Date one. There we go. Date one. Date one. What about, that one led to some debates. And I'm going to skip it because I don't want to debate that. Part D. Well, if you were to simplify the -2, -2, the quantity squared, doesn't that turn into 4? And 4 square roots 2? Everybody see the logic there? So if you follow PEMDAS, PEMDAS says parentheses exponents, multiply, divide, and subtract. Parentheses. In the parentheses is -2. Exponent is to the second power. So the square root of -2 squared would be the square root of 4, which would be 2, right? However, there's another way to look at this. You could look at this with those special set of eyes. And if you analyze what's going on with the functions, what happens with a square root and a quantity squared? What do those do to one another? They cancel one another out, right? So if you look at it from that perspective, the square root cancels out the squaring, so it would eliminate that and leave -2. So here I am scratching my head. Which one is it? I know it's shaking my head, but I'm scratching my head. Stroking my chin. That's SMC, I guess. Better stop with those. So which one is it? Is it 2 or -2? It's both? PEMDAS says it's 2. But if you analyze what's going on with the functions, it's -2. See what the Math Lamborghini has to say? Okay. So let's clear out the problem. So we want the square root of the quantity of -2 squared. And this says that it's 2. Now, let's look at it from a functional perspective. Let's look at it from a functional perspective. It's a square root of -x, the quantity squared. Everybody see what I got going on here? So what I'm going to do is I'm going to evaluate this function. Actually, you know what? I'm not going to do that. I put that -x in. Let me take that -x out and just put an x. And I'm going to evaluate this function. I'm going to evaluate this function when x equals -2 and see what happens. Evaluate it, find a value when x equals -2. And there it says it's 2. So even though the square root and the square cancel each other out, if you follow PEMDAS, The answer there is supposed to be 2, like the Lamborghini said. Any questions so far? We're almost home with this. There's just one more big idea here. We're going to throw variables into the mix, and these can get a little UGLY, you ain't got no alibi, you ugly. Yeah, you ugly. With variables, if the original index is even, this is a really important part of this. You would be remiss to not put this in your notes. That's why I'm taking my time writing this down. With variables, if the original index is even and a simplified coefficients variable has an odd exponent. I know this sounds like a lot, and it'll make perfect sense here once we look at an example. So with variables, in other words, when we're dealing with variables, numbers, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, etc. If the original index is even and a simplified coefficients variable has an odd exponent, we must put that term in absolute value bars. And I've got a beef with MathXL on this. I've got a bone to pick with MathXL on this. They are not consistent about it. There's going to be some exercises in the homework where 1 minute they're going to want absolute value bars and the next minute they're not. So when we're dealing with variables, if the original index is even and a simplified coefficients variable has an odd exponent, we must put that in absolute value. So let me give you a quick example what I mean by this. Example, let's find the square root of x to the 6th power. Everybody see what I got going on there? So what number multiplied by itself twice would give us x to the 6th? X to the 3rd, awesome, good. Because x to the 3rd times x to the 3rd is x to the 3 plus 3x to the 6, great. So this is x to the 3rd. So this simplifies to be x to the 3rd, okay? But this does satisfy all the conditions. The original index here, the original index is even. The simplified coefficients variable has an odd exponent. Here's this odd exponent we're talking about, this odd exponent right here, this 3. What we have to do is we have to put that term in the absolute value bars. So the answer is actually the absolute value of x to the 3rd. It's actually the absolute value of x to the 3rd. The reason we have to do that is this. You remember how the radican's not allowed to be negative? If we didn't put the absolute value bars around this, and suppose our x value that we plugged in was -8. -8 cubed is negative, right? So that's kind of why we have to do that. So let's see if the book has any more examples on this. Here we go. Square root of 16x to the 8th. When we do this, we kind of break it down piece by piece. Let's look at the numbers first, and then we'll go to the variables. What's the square root of 16? 4, good. And the square root of x to the 8th is x to the 4th, good. So it's 4x to the 4th. Now, the original index is even. This exponent here is also even. Since that exponent's even, we don't need to worry about absolute value bars, and we're good. That's it. We're done with this one. 4x to the 4th. Okay, that's it. In case you're wondering about if there's a quicker way to get that, to get this part of it, when we take the square root of x to the 8th, the square root of x to the 8th, it's kind of like taking x to the 8th and raising that to the 1/2 power. In other words, it's kind of like taking x to the 8 divided by 2 power. And that 2 comes from the index. So one quick way to think about it, divide the exponent of that variable by the index. Does that make sense? A little bit? Let's look at the next one. So what do we get for the a then in part B? In part B, we're going to get a to the what? To the 6 divided by 3. So a to the 8 squared. And what about b? It's going to be b to the 9 divided by 3. So b to the 3rd. Okay. Now, remember, the only time that we need to have that absolute value is if the original index is even, right? If the original index here is 3, we don't need the absolute values on this one. Okay. But I'll bet we will in number C. I bet we will in number C. Number C, what are we going to get? What's the 4th root of x to the 8th? X squared, good. And the 4th root of y to the 12th? Y to the cubed. Now, the original index is even. X is squared, y is cubed. One of those needs to be an absolute value of ours. Which one? The y to the cubed, right? So it's x squared, absolute value y cubed, and that's what we get for that one. Why does that one have to be in the absolute? Because here's the thing. If the variable had a negative value to it, and you cube a negative, it ends up being negative, and it would end up making that whole thing negative. Okay. You need the absolute value when the original index is even and when the variable exponent has a degree that's odd, when it's simplified like that. Yeah. Why didn't I do it on the one before, on part B? On part B, the original index is 3, and 3 is odd. Okay. So you will get a chance to practice these in the Math Excel. Let's see if we got anything else. There's these story problems. Don't let them fool you. And I know I'm guilty of not always looking at the story problems, but they're really easy. It says if the raw scores on a test range from 36 to 90, what is the range of the adjusted scores? So all you're going to do is plug in the raw scores there and evaluate it. It's not that bad. So that's all I got. Are there any shout-outs? Will Duvall? Anybody else? Guy Pert? Anybody else? Dr. Dre? Okay. Anybody else? Future Mr. Minnick? All right. He's going to like that. Anybody else? Well, it's been real. It's been fun. I'll see you next time. Have a great day.